Hello students, welcome to the Master Foundation program. Today we are going to discuss the very important model problems which are going to be appeared for entrance examinations, right. Let us go for kinematics 1D motion for the 9th class students. So, at this level they are going to know the related problems which are frequently reflected in IIT mains level examination. Let us see. Yeah, if you are going to take that, one model problem is there. You can take that one tap, just you have to see. First water drop, second water drop, third water drop. If you are going to see like this, so they are going to ask the problems based on this first water drop, second water drop, third water drop, time and the distance. They are going to frame the problems based on these 3 water drops. Let us assume, right. Do you know the height of the tap is going to be measured? Does it reach the ground? It is very clear. If they have given that height, is it possible to measure the time taken by that water drop to reach the ground? Easily you will calculate, it is not a big task. But if you are going to take that, this is that third one, this is the second one, this is the, please see, yeah, this is that, this is the first water drop, this is the second water drop, this is the third water drop. Let us assume. So, they are going to ask that, yeah, you have to note that it is going to be taken, yeah, this is height, they have given that height h. Just you have to take that h. Let us assume it is okay. But what type of problems they are going to ask that? So, there is a relation with respect to the time and the distance travelled. All right. If you are going to take that 2 parameters, distance and time, in case of 1D motion, always they are going to be associated, they are going to be having the relation. If the body or if particles are going to be in motion, there exists a relation between distance and time. All right, it is clear. Let us assume first water drop has been dropped here. So, if they have given that height, then the time taken, this is T1, this is T2, this is for T3. Time taken to reach the ground is going to be T1. So, this is for T2, this is for T3. Let us assume, right. If you are going to take that equal intervals, yeah, equal intervals of time, we have to take this one. This is very clear. That is what I am telling you. To solve for the distance, all right, the distance above the ground, the presence of second water above the ground, the presence of first water drop above the ground, just you have to take this one. If you know that there is a relation, there is a one consideration, equal intervals of time they are about to reach that. So, one drop, the time taken to release that one drop, it is going to be equal intervals. All right. Now, if you are going to take that T1, T2, T3. It's very clear, just we have to take that. Now, if you are going to take that, yeah, half a t square, it's very clear. So, you have to take that, yeah, that is S is equal to 0 plus 1 by 2 plus g t square. It's very clear. This is the generalized expression for that one. All right. Now, if you are going to take that, h is equal to 1 by 2 g t square. If you know that h value, you can easily calculate that t value. All right. You can easily find out that knowing h, we can solve for t. It's very clear. Now, you are going to get this problem. After getting that t time, after getting that time to reach the ground, so does it takes 1 second? Yes, 0.5 second. Just you have to take that. You have seen that is, yeah, you can take that. Yes, just you can divide that 0.5 second, 0.5 second. Is it clear? Let us assume it is going to be equal interval of time, that is very clear. All right. So, in this way you can analyze that concept and you will solve the problem. If they are asking you the height of the second drop, just the distance where the second drop will present, where that third drop, where the first drop. So, okay, it is first drop is released and it has reached, second drop, third one. Simply you will calculate that the presence of the water drop, the position of water drop, simply you can calculate that by getting this analysis, by knowing this one t. For the, if you know for the first drop, is it possible to extend the phenomena for second drop? You will apply the known parameters for the second drop and you will apply for the third drop also. We have taken that 3 drop. All right, this is going to be, yeah, this is going to be time, this is interval, time interval, this is going to be time interval. Just you have to get that. All right. Is it clear to solve the problem? Yes, it is very clear. So, at the first time if you are going to read the problem, try to read the problem, you might be having somewhat difficulty at first time if you are reading this problem, because you are not having that some idea about this program, about this case study. All right. So, if we have been discussed with whomever in earlier time or you have been interacted with this topic, then only it is easy. So, that is what I am telling you, what are the possibilities to frame the problems on a one topic. Just you have to say that, this is very clear. Very similarly, you can solve the problems, the ball, 2 balls are dropped from the tower. After the dropping the first ball, after first ball, 5 seconds later, second ball has been dropped. They have going to meet on ground floor, what is the speed of second one? If you know that, if you are going to calculate that height and time, just you can solve the problem. All right, it is very clear. Let us go for this one. This is the basic formula. This is also basic formula we have to discuss, right. Now, you can take this one. Yes, let us go for problems for this one, right. We have taken this 3-drop model problem. U is equal to 0, we have to consider, that is the case. So, it is very clear. Right. Let us go for the problems based on this concept. Yeah, it is very clear. The water drop falls at regular intervals from a tap. If you are going to take that regular intervals, that is very, very important. T1, T2, T3, the time interval, the time lag between these 2 or 3 or any other water drops is going to be regular. Regular means it is going to be knocked at equal time. It is going to be released at equal time, right. Time intervals from a tap 5 meter above the ground. Yeah, they have given, right. So, just you have to take this one, right. All right, very clear. You have to take that. This is 5 meter, I hope so. All right. So, that first drop has been released. Yeah, it is going to be all right. Yeah, it is reached that. Again, you will take that one more drop presence here. Yes, it will reach the ground. It is going to be ground. All right. What they are asking, just you can see that 5 meter above the ground. They are going to ask that the position of second drop above the ground. Simply they wants to know about that position of the second drop with respect to that ground, or with the, just you have to see that. Okay, let us take that. Yeah, the first drop, yeah, we will use this space, no issue. The first drop travels 5 meter distance. Yes, 5 meter, it is very clear. So, you would like to know that 5 meter, just you have to apply. Yeah, you have to apply for that one, that is equal to u t plus half a t square. So, it is going to be 0, it is going to be 0 for that. Now, you can take that 5 is equal to half g t square. Let us take that g is equal to plus 10 meter per second square, it is very clear. Therefore, 1 by 2 10 t square, it is very clear. So, you will get that t square, t is equal to 1 second. So, what you have been obtained from this one? So, the time taken by the first drop to reach the ground has been calculated. From that given condition, water drop falls at regular interval of the time, that is very clear. 1 second, for the first drop it is going to be 1 second. Oh, yeah, it is going to be, it has been. If we are going to consider that for second drop, yeah, it has been traveled the distance, right. Yeah, you can take that 1 second you have been obtained for first ball, first drop for the yeah. Just you have to consider this is 0.5 seconds. Very clear, you are going to get this one, or 1 by 2 t t is equal to, just you have to take that t is equal to 1 by 2 second, just you have to consider it can reach that. You are going to consider regular interval of time, you can get that easily. So, let us assume it is above the, how far above the ground, let it be, we will take this, yeah, we can take this color. So, this is going to be x meter from the ground, let us assume, right. Okay. We have to erase this one. This is about total, the total distance is going to be 5 meter, all right. So, you have to consider x, that is very clear, you are going to get this one, all right. So, you can easily find out that x is equal to, right, yeah, does how much distance does it has covered after the release, just you can see that is u t plus half g t square, it is going to be 0, x is equal to 1 by 2 into 10 into 1 by 2 square, because t is equal to 1 by 2 second, just we have to consider this is the case. So, in this case we can solve the problem 1 by 2 into 10 into 1 by 4, just you have to consider, right, you can take that. So, 4x is equal to 5, x is equal to 5 by 4, just you can take that 1 to 5, just you can take that, yeah, you have to consider that meters, what we have seen meter. So, you have been find out that yes, we are going to take that for the first one, it has been calculated in terms of h, that is this is going to be h1, right, whatever. So, for this one you can take that this is h2, yeah, please take that, yeah, this is going to be h2, yes, you can take that, it is very clear. h2, yeah, it is going to be clear. So, if you are going to get this subtraction, just you can take that this is h2, right. So, x is equal to h1 minus h2, you are going to get this one, it is going to be h2. You wants to find out x, that is 5 meter minus 1.25 meter, it is very clear. You wants to measure the position of height of the ball, just we have to get that above the ground, the presence of ball above the ground, where does it will present above the ground, that is the question, it is very clear. So, how far above the ground is the second drop at that instant, when it has been reached, second drop is at the middle, just you have second drop is going to be reached this position, you can assume. Time it has taken 1 second, for the second drop it is going to be 1 by 2 second, but the distance is not going to be same, yeah, it is at somewhere else. At equal interval of time, does it travels the equal distance? No, it has been travelled h2 distance, just we have taken h2, it is very clear, we have been solved that one, right, you have to get that 3.75 meter, very clear. So, in this question what you are going to lay, please see that first ball has reached that h1 distance height, that is second ball is at H2, right. So, you are going to get this, what is the distance between the second ball and the ground, just above the ground, the position of the second ball, second drop, we are going to call it as drop above the ground. It is very simple. Let us see the answer, we are going to get this. Okay, we are getting this one. Very simple, we are going to get this one. Once again, just we have to see that first drop travels 5 meter, it is very clear. So, they have given the height, yes, and we have been calculated the t for the first ball to reach the ground. At the same time, we are focusing that at regular intervals of the time, the water drops are going to be released. For the second drop, it has been presented at H2 meter distance. H1 is the total distance travelled by the first drop. So, you know that H1, this is the H1, alright. So, this is H2, just we have to calculate H2, it is going to be solved with the help of this one. This is H2, right. It is going to be 0 because u is equal to 0, it is going to be 0, alright. Now, you have been calculated H2, then you are going to take that x, you need to find out that x value, just x represents that the distance above the ground level, where does it possess, the distance between the second water drop and ground, that is very clear. You are going to find out this one with the help of this final expression. You are going to split into two parts. First part is for the first drop, time taken. Second case, you can take that for the second drop. You need to get the time. You need to estimate the time. That is 1/2 seconds, because for the first drop it is going to be 1 second. That's it. Continuously they are going to release the drops. Alright, just you can go for another problem, it is very clear. Yeah, a body starts from rest and moves with uniform acceleration. The ratio of distance covered in nth second to the distance covered in n seconds, it is very clear. So, we are going to take this problem. Yeah, body, if you are going to take that in nth second, the distance covered, it is going to be identified as n is equal to u plus a/2 into 2n minus 1. This is okay. Yeah, this is distance covered in nth second. In nth second, Sn. Now, you are going to get that the distance covered in total time, just you can take that the distance covered in n seconds, that is S is equal to, just you have to take another color to, yeah, write down, that is S is equal to u into n plus 1/2 into a n square. Alright, you are going to have this, right, u is equal to ut plus half a t square. This is the case, we are going to get that. Yeah, what they have given, t is equal to n, just you have to get that here, t is equal to n, you can take that, going to be n, it is very clear. So, this is the equation number 1, this is equation number 2, alright. Now, you are finding that ratio, I hope so, they are asking that ratio of distance. Okay. Yeah, you have to consider that a body starts from rest, that is very clear. So, does it goes to 0? Yeah, u is equal to, a body starts from rest, Therefore, u is equal to 0. All right, it is going to be 0. Initial velocity is going to 0. Now, this is it, so that Sn is equal to 0 plus a by 2 into 2n minus 1. S is equal to 0 plus half a n square. Just you are going to find out that ratio, that is enough, I hope so. Please get that ratio. Therefore, Sn by, it is very clear. Now you are going to get this one. Sn by S is equal to, right, a by 2 into 2n minus 1, all right, a by 2 into 2n minus 1 whole upon half a n square. All right, just you are going to have the cancellations, if any. All right, 2, 2, just you are going to get that a, yeah. Now you can take that 2n by n square minus 1 by n square. Therefore, 2 by n minus 1 by n square. All right, it is very clear. Please have the ratio. Yeah, in that given options, which is going to be suitable for this one? Yes, yes. Two by n, yeah, you can take that. Just you have to look into that matter. We are going to take that 2 by n. It's going to be yeah, 1 by n square. Okay, 2 by n minus 1 by n square. It's very clear. So this is going to be correct one. Yeah, if it is going to have that. Okay, all right. It's very clear. If you are going to get this one, 2 by n minus 1 by n square. All right. Okay, it is very simple question and basic model question. Let's go for another one. It's very clear. The numerical ratio of average velocity and average speed. Yeah. While you are going to take that average velocity and average speed, it's a ratio that is going to be average velocity yeah. So while you are going to take that distance and displacement, these are the two parameters to know that if a body which is in motion, the distance is going to be increases. All right. Now while you are talking about that speed and velocity, you have to take that velocity. We have to consider displacement. All right. You have to take that. All right, it's very clear. Now you can take that second one, speed. It is the parameter depend on distance covered. So if you are going to take that distance is going to be greater than displacement. So at sometimes it is going to be equal. If it is going to be in the straight line path. In this case both are equal. So, if it is going to be having that, in this case you are going to get this. Yeah, at that time you can take that average, just you are going to take that average displacement and average. So, it is going to be greater, right. You are going to take that average speed, right, which is going to be greater, which is going to be lesser. Just you have to imagine, while you are going to take that parameter average velocity and average speed, we are going to take that at different intervals. In this case only just we are going to take that in one interval, it is going to be 1. So, if you are going to take the ratio, it is equal to 1, but in this case, yeah, it is equal to or less than 1. In this case just we have to take that is yes, always you are going to take that as compared to that velocity and speed. If you are going to take that, in this case along 1D in the straight line path, it is going to be very clear. Sometimes it is going to be following the different paths, you are going to take that. Yes, you can take that. In this case different situations you can explain that. This is going to be the correct one, equal or less than, but it never greater. So, is there any another option? Always less than 1, always equal to 1, always more than 1, there is no possibility. Yeah, this is going to be correct in all the times. Alright, let us go for another one. Yeah, right, you can take that another problem. Yes, distance travelled by the body is directly proportional to the time taken, then its the speed is very clear. First of all, distance travelled by a body, yeah, is going to be is d. Whenever that particle which is in motion, you have to get that time. You can take that distance is function of time, function of time. You can take that distance is equal to at plus bt square minus ct cube. You can write down in the form of the function. Yes, it is very common observation. When the distance is going to depend on the time, as the time increases, distance is also going to be increases, no doubt at all, distance is going to be changed. All right. Now, distance is going to be directly proportional to, yeah, you can take that, yeah, what they are directly proportional to, it's going to, it's directly proportional to t, very clear. So, you can take that d by t is equal to constant, whether it is in the continuous motion, you can get this one like that. What we have taken, that is d is going to be exhibiting this. All right, if you are going to take this one, it is at t1 interval, t2 interval, just you have to write that the total distance covered by the body can be expressed as the function of time, it is very clear. So, it depends on that time. So, d by t, it is going to be constant. Yes, you can take that. So, remains constant, right? The speed is going to be constant. Whenever it depends on the time, if you are going to take the time is a one reference parameter for the distance covered, distance travelled by that body. Whenever it is going to be depending on time, you can take that d by t is equal to constant for this case. For this case it is going to be, for this case it is going to be very clear. Alright, let us go for another one. Yes, two trains each of length 100 meter or running parallel on tracks. Okay, it is very clear. Two trains they are going to be first one and second one. Okay, all right. If they are going to move, yeah, here two cases are there. Yes, they are crossing each other and they will overtake. You have to take this one. Overtake, just you have to take the consideration. Two trains are there crossing, they are crossing each other, they are overtaking, just you have to take that. You can take that, this is the u and v. Now you are going to take that relative velocity, just you have to take that relative velocity. Yes, here the relative velocity is going to be taken, that is Vr is going to be, yes, u plus v. Here Vr is equal to, just you have to take that u minus v, very clear, here u plus v. Because of the direction, just it is the case you have to take, this is the first case, let us assume what they have given in the problem, one overtakes, this is the first case, overtakes. Yeah, cross each other, but what they have given, each of length is going to be 100 meter. If even though they are going to be overtaking, they are going to be crossing, just total distance is going to be 100 plus 100, that is 200 meter. Alright, it is very clear. So, you have to take that, here also 200 meter, here also you have to consider 200 meter. Alright, this is case 100 meter, this is also 100 meter. They have been covered that 100 plus 100, that is 200 meter. Alright, it is very clear. The distance travelled, just you have to consider the distance, overall the distance is going to be 200 meters. Alright, they are going to be in parallel track, but the time taken to cross and time taken to overtake, just you have to take that, just it is going to have that they are crossing, right, overtake and crossing, just they are going to be having that overtake, it is going to be in the same direction, it is going to be in the opposite direction, it is very clear. What is the time? In this case they have given the time, that is t1 and t2 seconds, just it is very clear. So, you can calculate that t1 is equal to 200 by, what about that, u minus v, just you have to get this one. Alright, here t2 is equal to 200 by u plus v, it is very clear. In this way we can solve the problem. So, what they have given for this case, overtake 20, what they have given 10. Now, you can solve the problem and get that this is the correct one. By applying that you can easily find out that. Okay. Okay students, thank you very much, have a nice day.